Hi, John Feo.
Hi.
Thank you for visiting us at our booth at Supercomputing 11 conference. You are also one of the first users of the XMT, Cray supercomputer. Can you tell us what you are doing with this computer?
So we've had interest in the XMT for a long time. We have a large project at the laboratory that started about 3 years ago. We have a XMT1, 128 processor XMT1, so we were one of the first sites to get an XMT1. And we're using it to study highly irregular applications, mostly graph algorithms, to do algorithm and application development in dynamic Bayesian networks, emerging graph patterns, computer security, vulnerability analysis. We also have work in bioinformatics and a lot of work in semantic search and semantic database development. We're also looking at, we also have projects in compilers and runtime systems to improve the compilation of code, programming models for highly multi-threaded machines like the XMT. And we also have considerable work in architecture design and development, looking into the future on what new versions or next generation systems might look like. In particular, trying to use the developing technologies in many-core and multi-core, and the oversubscription of threads on many-core systems in trying to drive very high utilization of network bandwidth. So the HPC community has been very good at designing systems for applications with high temporal and spatial locality. These tend to be in the area of physics and molecular chemistry. So they're not particularly good at programs which exhibit little or no locality. So graph algorithms, in particular semantic search and knowledge discovery in a huge database is difficult to do on these systems. So the XMT and machines like it open up the possibility to do these types of applications at very high scales, in both in terms of memory and data, as well as in time to solution. So, and we see, so this is definitely a new area for high performance computing, but one with, I think, large market possibilities. Companies like Facebook and Google, the banks, lots of work in the area of law enforcement. So these are areas that high performance computing hasn't really touched yet, but potentially machines like the XMT can play a large role.
You are at the Pacific Northwest National Lab. How do you proceed to involve new users to this new system? Do you ask them? They ask you?
Right. So with the XMT1, we had the largest open system. So we make accounts available to new users, and we have both domestic users and foreign users on the machine, both in academia and other national laboratories, even some businesses and industry collaborators. So typically, we go out, we talk to them, they learn about the machine, they have problems they'd like to solve, we open accounts for them, and then we provide user support and consulting to help them move their codes over to the machine or develop codes for the machine, work with them on the optimization. The programming model for the XMT and machines like that are significantly different than either the shared memory models like pthreads or the distributed memory models like MPI. So it's a machine that's easy to program, but you have to think differently. And getting people to think differently is difficult. And there's a learning curve that can take some getting used to. But once people understand the machine, then it's actually quite easy to program, and they can get a lot of work done.
Do the people have to rewrite the code from scratch? And are this code a large one or a smaller one with respect to other codes, for example, for meteorology, climatology?
Right. Well, the key is just to, you do have to rewrite. The machines like the XMT really require, hundreds, if not thousands of threads per processor. So it's really a highly threaded programming model. So you need to find that level of parallelism. Now, typically, you don't have to rewrite the whole code, just the computational kernels of the code, but you do have to take sort of a different approach. And, we work with users to do that.
Are there some results that you are already proud about now and about science results of?
Yeah, so we're not a production shop. We don't run large production codes. We're more of a research shop. So our work is mostly in terms of algorithms and library routines. So things like between centrality, shortest path, triad analysis, some clustering algorithms, inverted hash tables, things like that. We have some pretty good results on, yeah.
Could you give me a last example of application in science, more specific?
So in science, we're not really in the science realm. I think one area that we're working in a lot is in the area of semantic databases, and so developing algorithms to search large corpora of information, structured text in particularly is really where we have the most work and the most results.
Okay, thank you.
Well, thank you very much, and we look forward to working with you guys. And if you need any help in terms of users or support, we'd be happy to help out and collaborate.
Sure. Thank you very much.
Bye.